Today I'm going to explain about the PVTs for security in web application. So for question A, question one, I'll explain the steps and the description. For the question 1A is use appropriate tools to conduct a comprehensive assessment of the application, identifying and mitigating any SQL injection vulnerabilities that could potentially expose sensitive customer data or compromise system integrity. So the tool I have used is using DBWA. For that, start XAMPP and enable Apache and MySQL. After that, visit http localhost dbwa/login.php and then login with default credentials, admin and password. After that, navigate to SQL injection from the left menu. So after that, enter ID 1 to retrieve a normal user's details. Enter the payload 1 equals to 1 to test SQL injection. After that, the system returns all database entries confirming poor input sanitization. And the tool 2 is SQL map. For SQL map, open developer tools and then click application, then click cookies and then copy PHP session. So after copy PHP session value, download SQL map from the command prompt. So after you successfully install the SQL map, now you can run this command. After that, you will get the database available as below. So run this command to get all table in DBWA database. The results show that we get 2 tables, but now we just need the users table only. So extract the users table. SQL map displays username and as password. So the mitigation is implement multi-factor authentication MFA. MFA should be enabled particularly for administrative accounts to provide an additional layer of defense. Implement proper session management. Session tokens should be generated using strong randomization methods and have sufficient length to prevent prediction. And the third one is avoid the use of predictable credentials, default or easily guessable administrative credential. Example, admin or admin must never be used. Finally, enforce server-side authorization control. Implement strict server-side authorization checks for every request to protected resources. The system must validate whether the authenticated user has the necessary permission before granting access. So question B. Additionally, you are concerned that the web application authentication mechanism might be vulnerable to bypass technique. To bypass technique, potentially granting unauthorized access to sensitive features or user accounts. Display method to test authentication mechanism resilience against common bypass technique, including brute force attacks, password spraying, and session fixation. So brute force attacks. So brute force attacks, you can see the login bracket username comma password bracket and then correct underscore password equals to secure pass 123, the for loop and then print lines. So the mitigation is implement rate limiting, account logout after repeated failures, require MFA on suspicious items, log unusual authentication patterns. For password spraying, we got accounts equals to bracket dot bracket, a small set of test accounts with known passwords, common underscore passwords bracket dot bracket, a small list of popular or common passwords that attacker sprays across many accounts. Nested for loops. The outer loop iterates over the same small set of passwords. So the print lines. So that is how password spraying simulation by code explanation. So mitigation, require MFA across the user base. Best mitigation, detect and alert on the pattern, same password attempted against many accounts within a time window. So for the session fixation, visit https policyc.cdos.edu.my, click inspect and application and cookies. Observe session changes during login. So open again at part application on inspect and we check back the cookie section. As you can see, the value change and session is guaranteed and the session is secure. We can only see that the website in HTTPS. So the mitigation for the session fixation is critically important as it prevents attackers from hijacking user session by ensuring that session identifier regenerate upon authentication. This practice protects sensitive data and upholds the integrity of the system. So session management best practice: set session timeout, destroy all session, regenerate session ID, use secure cookies. So that's all from now. Thank you.
I am Jeevan Ravishankar. My number 01DDG23F1071. So now I'm going to talk about question 2, which is secure session management, ASP.NET. For question 2, I will explain how to securely manage session in ASP.NET. In a high security environment, session protection is important because users access sensitive data. ASP.NET provides strong security features such as PBK DF2, password hashing, secure login, and built-in CSRF token handling. To secure session cookies, we enable HTTP only, prevents JavaScript from reading cookies, then ensure all cookies travel over HTTPS. So ASP.NET also uses anti-forgery token. With proper HTTPS, secure cookies, token validation, and short session lifetime, ASP.NET provides strong session security. So let's talk about question 3. For question 3, I implemented SSO using Keycloak. First, Keycloak was installed and started through the terminal. Then we logged in with the admin account. We created a new realm to manage users and application under the SSO system. We added two applications as clients, My Test Client and Project App. Both used OpenID Connect with standard flow. We set the root URL and redirect URL so Keycloak can return users to the correct app. After logging in once, both applications become accessible without re-entering credentials. This confirms SSO is working successfully. So that's all from us. Thank you.